What's up, people, and welcome to my tutorial in Introductory to Blockchains. So in this tutorial, we're going to continue on the topic of the chains, and we're going to introduce another interesting aspect. Now we're going to introduce a second node into the equation. So this is node 2. I'm just going to start it up and see what it gives. And now it's currently just printing out its blockchain, right? So you can see it has block number 0, which is the Genesis block. It has the same nonce as previously. And it also has some other block right here, which is a different kind of transaction that the other guy right here, the node 1, is doing. So let's have a look at how the configuration for that node looks. And in the configuration folder, you can find it here in node 2. And what it does, it buys something from node 1 with the amount of 100. So let's just illustrate what this is, right? We have this node 1, and what he's doing is that he has the Genesis block, and then he is buying he's buying from the other node, right? So he's buy from node 1, and then he is again buying from node 1 like this. Then we have the other guy, right? That is node 2. And what this guy does is he has the Genesis block, and then he's buying from node 2. This is what happens, right? So this guy has 3 blocks, while this has 2 blocks. And you can see the Genesis block and the block, right? So what does this mean in practice? So if you imagine this being a real scenario where you have 2 guys buying from each other, what happens is you create these transactions from your accounts. If you remember here, we debit our account and we credit, we credit our own account, and then we debit some other account when we are buying from someone else. But this means that how do you keep this in sync? For example, how do you not guarantee that if someone is buying from you or selling from that you'd actually have the right amount of cash on the balance on your account is correct, basically. And you can imagine a scenario here that when this is run and this is also run, there is no global state. That's what I'm trying to say. There is no global state here, and who is going to win? Who is going to have precedence over the other? Is this guy right here? Is this going to decide what the balance of the node 2 account is? Or is this guy right here? He's going to be in charge of keeping the balance for node 1, right? And this is a bit problematic because when you run stuff like this on the internet, maybe you don't have internet connection all the time, and also internet transactions like this. I mean, the network state is not synchronous; it's asynchronous, which means that stuff like this can be run in parallel for all that you can know. You don't know which one was run before the other, and the way blockchain resolve this issue is pretty simple. It just keeps the one that is the longest, right? But that also means that you can have transactions like this, and I mean they're just kept localhost, right? They're kept on the local node, and that is fine. The chain is still valid. You can keep on creating blocks like this for all eternity, for all that it cares. But as soon as you want to share that block with the chain with someone else, then you have to distribute the chain to some other node, like for example node 1, saying that, hey, I bought some stuff from you and you should update your blockchain with the chain that I have, right? And then node 1 is going to look at the chain that it received and say, well, you know what, this chain is longer than mine, I'm going to merge it, and then I'm just going to invalidate all the transactions that I have in my chain that is smaller and just replace it, and then I have to redo all the transactions. And as you can imagine, there are some problems with this, as we can dive into this a little bit more in depth later. But this is the simple explanation of how the blockchains are merged between nodes. So when we look at this node right here, it only has 2 blocks on the blockchain. And it hasn't distributed its chain to the other guy here, the node 1, yet, because it's not up and running and they have no way of communicating with each other, right? And the way I solved it in the demo is that they use HTTP. And what they do is that you just have a basic best effort broadcast. So you broadcast in a cron job here every 5 seconds. You broadcast your blockchain to every node from the topology that you know about, which is hard-coded, but you can have some topology manager if you like. And it's going to grab the blockchain and then it's going to broadcast it to the other node, saying that, hey, here's my blockchain, right? And this is the broadcasting part. It broadcasts the blockchain from the local node. And this is the receiving part, where it receives the blockchain from someone else. So it prints out some stuff here, and then it grabs the blockchain that it received and trying to merge it with its own. And when it's trying to do that, a couple of different scenarios can happen when it's trying to merge a foreign blockchain. And that is a good place to stop for this now. And I hope you guys liked it. If there is any question, please leave it in the comment section. And I hope to see you in the next tutorial.